Hello everyone, and today I'll be doing my presentation on Quasars, and I hope you enjoy, because I certainly did. But let's get started. But what exactly are Quasars though? A quasar is a type of active galactic nuclei which faces partially away from our view and are the brightest objects in the universe. Wow, that's crazy. How do they form and work though? They form when the central supermassive black hole of a galaxy eats a lot of matter very quickly, which causes an accretion disk. You guys probably already know that if you watched the rest of my black hole videos. I love black holes. And even a relativistic jet to form. Because of extreme friction and gravity, since matter in the accretion disk can go up to 99% the speed of light. That's really fast. Lots of heat and radiation is generated, such as radio waves and X-rays. It usually feasts for around a few million years, but when it is done, the galaxy is damaged, as gas near the quasar is way too hot to form stars, as particles are really spreaded out, apart, you know what I mean? And mostly collide with each other, which resists gravity. So it is actually better to have cold gas in order to form stars, since gravity can compress the gas much more easily. It's very interesting. I never really thought about that. These beasts can also form by galactic collisions. So imagine 4 billion years from now, right? Andromeda and the Milky Way, our galaxy, will collide with each other. Imagine how big of a quasar that will be. That will be pretty crazy. Hopefully, we're still around to witness it. And yeah, because by then, the sun would already be a red giant, and the explosion that'd be caused by the collision would be very powerful. So hopefully we'll be okay by then, and we're nowhere near the red giant sun. But yeah, it'll be interesting to see. Quasar history. So basically, what's the history of us discovering quasars? Well, let's find out. When the very first radio telescopes and X-ray telescopes pointed at the sky in the late 1950s and early 1960s, they saw bright blobby dots of radio waves and X-rays. Then, in 1962, an event known as a occultation. That's a very interesting phrase. I never heard of that either. Learn something new every day. Happened where the moon passed in front of one of the brightest of these radio dots. The radio dot was Object 273 in the brand new Cambridge radio catalog. 3C273 for short. Astronomers began to observe 3C273 through optical telescopes and splitting the light into a spectrum. And as you can see down here, very interesting, right? Compared to a star, an average star, the spectrum is different entirely. So astronomers decided to classify these radio blobs as quasi-stellar radio sources, which would later be called a quasar. And now, you know how humanity unveiled one of the most powerful celestial bodies in the known universe. Quasars! I love quasars. But yeah, they're very powerful. Now, let's see other types of active galactic nuclei. This right here is a radio galaxy. And you're like, hey, it's the same thing. Why do they have different names? And it's because, yes, it's the same thing, but they're defined by angle. So a radio galaxy is pointing directly away from us. So it has to be a perfect 90 degrees facing away, the jets, in order to be classified as a radio galaxy. And the Blazar, much cooler and scarier name, it gets its name when the jet is a perfect 0 degrees, pointing directly at us. And you can even see bits of the black hole itself. It's pretty crazy. And a quasar is basically just in between these ranges of extreme degree. So, it's pretty cool. Now, time for the funnest part. You need fun facts in order to have a presentation, you know what I mean? So, without further ado, fun facts about quasars. Fact number 1. Did you know that the average quasar eats around 100 Earths of mass per minute? Which means the average annual growth is 48,384,000 peanuts, or 48,384,000 inches, since a peanut is an inch. At least I would say so. And if the Earth was crushed into a black hole, it'd be either a centimeter, so the size of a pea, or a peanut. And I realized that it's just getting this much growth, which kind of seems like a lot, but compared to the rest of the cosmos and our black holes, not that much growth. You know, just crazy to think about, because sorry, this is gonna take a while to explain. Like, when I was much younger, right, I thought, hey, when a black hole, I get an Earth size as soon as I eat like an Earth mass, but no. I realized that it's still the same density. Like, it would become the density of a black hole, so it's just gonna get a peanut size of growth each time it eats an Earth. So, yeah, very interesting that I realized that like a month ago. I'm like, oh, this is very interesting. Now, on to fact number 2. Did you know that M87's jet is so long that it could stretch from the sun to Pluto and back 1.5 million times, which would be 117 million astronomical units, or 1,850 light years. Mind-blowing. That is massive. Massive. Look at that. Look at that jet. I think we actually, yeah. We got a picture of M87. Beautiful, beautiful. Very first black hole picture. Maybe I'll do a video on that too. Fact number 3. Did you know that this image is awesome? You know what image? This image. This is the Hubble Space Telescope's 100,000 yeah, I got that right. 100,000th observation, it seems like here. And what's cool about this image, I actually love this image. This right here is a star, just a couple hundred, you know, just a couple hundred light years away. And this looks about the same, but this is 9 billion light years away. So it's a telltale sign that this is a quasar. So that's just crazy. Imagine how bright that'd be if that replaced our sun. Just look up at the sky, like your face is just melted. Ah, man, that's bright. Imagine, like, crazy, absolute madness. Then we have sources. And yes, this includes Vsauce, and all and all of them guys, you know, and some articles too. So yeah, I'll put these in the link in the description. Amazing sources. And then the end, just the explosion. I guess that's accurate, cause but yeah, as you can see, I love black holes. I especially love quasars. So I hope you love them as much as I do now. I hope you learned something new, and I hope you guys have an amazing day. Okay, have an amazing day, and we'll see you in my next one. Bye. Bye.